Most of the software projects fail because of bad design decisions made in the first month of coding. And here's the kicker. Most of these failures could be prevented by following 5 simple rules that every professional developer swears by. These rules are called solid principles. Before we dive into solid, let's establish what is meant by design principles. Think of them like architectural blueprints for software. Just as building needs a solid foundation and logical structure to avoid collapsing, your code needs fundamental rules to prevent it from becoming an unmaintainable mess. Design principles are guidelines that help us write code that's easy to understand, modify, and extend. When you follow these principles, you create software that doesn't break when you need to add new features or fix bugs. Let's go through each solid principle and try to understand them. S stands for Single Responsibility Principle. It means that every class should only have one reason to change. Let's look at a real code example. Here's what not to do. See the problem? This user class is trying to do everything. Store user data, handle database operations, send emails, and generate reports. That's 4 different responsibilities. If the email system changes, you have to modify the user class. If the report format changes, you modify the user class again. Here's the solid way to write this. Now each class has one job and one reason to change. The user class only handles user data, user repository only handles database operations, and so on. Much cleaner, right? Now that we understand single responsibility, let's add the second principle. O stands for Open Close Principle. Software should be open for extension but closed for modification. This sounds contradictory, but it's actually brilliant. Here's the wrong way. A function that calculates area but violates the open close principle. Every time you want to add a new shape, you have to modify this function. That's risky. What if this function is being used in 50 different places? Here's the solid approach using the open close principle. Beautiful. Want to add a new shape? Just create a new class that inherits from shape. No existing code needs to change. You have extended functionality without modifying existing code. With single responsibility and open closed under our belt, we are ready for the third principles. L. This stands for list of substitution. This principle states that objects of a parent class should be replaceable with objects of any child class without breaking the application. Here's a classic violation of this principle. The problem? Penguins are birds, but they can't fly. If your code expects all birds to fly, a penguin object will break things. Here's the LSP compliant solution. Now you can substitute any flying bird object without surprises, and penguins aren't forced to pretend they can fly. Building on what we have learned about interfaces, the fourth principle, I stand for Interface Segregation Principle. It says, don't force classes to depend on interfaces they don't use. Think of it as no bloated interfaces rule. Here's what happens when you violate this principle. See the problem? We are forcing robots to implement eating and sleeping methods they can't use. Here's the LSP compliant solution. Perfect. Classes only implement the interfaces relevant to them. No more robots pretending to eat lunch. Our final principle brings everything together. D stands for Dependency Inversion Principle. High-level modules shouldn't depend on lower-level modules. Both should depend on abstractions. This is like saying your car's steering wheel shouldn't be hardwired to a specific tire brand. Here's what tight coupling looks like. The problem, order service is hardwired to email sender. Want to switch to SMS notifications? You have to rewrite the order service class. Here's the dependency inversion solution. Beautiful. Order service depends on the notification service abstraction, not concrete implementation. Want SMS instead of email? Just inject a different notification implementation. No changes to order service needed. Here's your solid principles transformed from academic concepts to career skills. When you follow these principles, you create code that's maintainable, testable, and scalable. Exactly what every good developer wants to see. If you enjoyed this content, feel free to hit that like button and subscribe for more. Thank you so much for watching. Have a great week.